Over the last couple of months, I've been learning more and more about this 65265 microcontroller from Western Design Center. I started with their SXB, which is this little utility board, and that's been great to learn on. I spun my own version of that board, essentially the same thing, but with a ZIF socket for the flash and an extra chip to help me do some address decoding beyond what the 265 itself has built in. You can see I've modified these boards to support this PIB, or a parallel interface bus, between the two boards, and I had a video where I had that up and running. And I've connected all kinds of different peripherals, LCD, a 2-line LCD, a TFT LCD, a PS2 keyboard, and some of that I was doing with a combination of these boards plus a breadboard with some of those peripherals connected. And that was getting pretty messy, so I said, okay, I need to consolidate that into a PCB. I put out a couple of posts, a video about really building a large board that might consolidate a lot of that, and then I decided to split that board for cost factors. Just really same functionality, but split it in half, and it really cut my cost in half. And I ordered up those boards. And so if I set these off to the side, I have received in those boards, and this is what they look like. And so what you're seeing here, and I'll try to hold this where the maybe the light doesn't reflect off of it as badly. I'll just put something underneath it here if I can find the right spot. So what I have here is, this board that really gives me all kinds of functionality that I was previously working with, plus some. And so what I've gone ahead and done is basically take this board, and I've gone through the assembly. And what I did is I started with just really the core, talking about the microcontroller and my USB to serial and an oscillator along with the 32 kilohertz crystal and my decode chip and power connection. And that was about it, just to see if I could fire this up and get into the Mensch monitor on the microcontroller, and that worked fine. And so then I went ahead and I populated the rest of the board. And interestingly, as I have done that, I now have this as my board. But what's interesting is everything has fired up on first time. So I was kind of surprised by that, quite honestly. So let me walk through what's on this board, and then I'll fire this up and kind of do a quick walkthrough of this. So this board here, I'll start with just power coming in. I've got a DC barrel connector coming in here, and the camera's probably not going to focus on this the way I have it set, but there's a DC barrel connector here. There's another power connector that is this style of a connector, which I prefer these. I think they're called a Saber connector. And so when I get to connecting this up, I'll use this same little box I've been using coming from my benchtop power supply, but then I have this nice, fairly robust connector. So pretty good size gauge, really nice cord that I made here. And that connects and locks. It clicks and locks in both there and to this box. And when I go to add my second board, which is going to sit, above this, it will have another connection on this box on the other side that I can pull another power cord off of. So I have flexibility in my power, DC or that Saber. I have the microcontroller, of course. I have my FT232 going to a USB-C connector. I have a PS2 keyboard connector along with the necessary inverter for that, and there's some ICs underneath this screen that are doing shifting, and also my versatile interface adapter for the keyboard and the LCD here, the 1602 LCD. I've of course got a 32 kilohertz crystal down here, 32 point something, and then I put in both the support for really, and let me just grab a pen to point this out as I go. But I've added support down here so that I have both that onboard 32 kilohertz, and I can put an onboard whatever I want to run for a crystal, 8 megahertz as an example, or I can use this CAN. And so I also put in a spot for an oscillator can here. And I'm running at 10 megahertz right now, and that's running fine. It was interesting. I did test it with just the core, and it ran fine at 12 megahertz. But once I've connected everything else, 10 is looking to be the ceiling on this specific board. In addition to this, other things I've done, I put in a switch to select which on my flash ROM, which 32K section does the processor map to. By default, it maps to the top 32K of the 128K here, but I can just flip these switches and basically boot up off of a different 32K section of that flash ROM. And that also freed up pins so that I can do this PIB connection to my other board when I get that. That was a modification I had to do to these other boards, is I actually had to disconnect those address lines, 2 address lines that were being used for something else that I needed to use for my PIB connectivity. But now I've simply, instead of those address lines, I've used a switch, which this is great. Lets me still select it, not programmatically select it. I have to turn it off, flip which 32K I want to use to boot up off of. But that's kind of handy and a better setup for what I'm trying to do. I've got the reset. I did put in a little supervisor down here and really it's a delayed startup is what it is. So I'm not really monitoring voltages. I guess it does monitor voltage, and it does have a delayed startup. It does not have a watchdog, but the WDC265 has a built-in watchdog capability, if I'm not mistaken. And I'm not using that yet. I did also add a little transistor and a piezoelectric speaker that I will try to work with in an upcoming video. I did add, in addition to the 32K RAM, I added another half meg RAM, so 512K static RAM up here, and I added a secondary flash ROM, another 512K. So I've got the 128K, of which 32 is usable, but then I have a full 512 here that's usable. I have here a little dual port static RAM so that this microcontroller and the other board, the secondary board that's going to go with this, can also connect to and communicate with that same static RAM. And that connectivity to the secondary controller is through this little connector. This is an EBBI connector, and it's a 68-pin connector, and that's really doing all of my connections between this microcontroller and the secondary when I get that board in and see if I can get that one up and running. And as a reminder, that secondary board I'm treating more as an audio-visual board, so it's going to have a VGA, a low-resolution VGA output, audio output, and can maybe offload other tasks from this microcontroller, connecting through a bunch of connections here over, and then on top of that I added this dual port static RAM that they're both connected to. I've got my LCD, and as I mentioned, I've got a versatile interface adapter underneath it, along with some shift registers to support the keyboard. I've got a larger GAL chip. This is a 22V10. Previously, I had a smaller version of a GAL chip, but I wanted more flexibility down the road, so I've added 4 more address lines coming in, and I have 3 more control outs that I can use to enable other devices that I've yet to hook up to this. Continuing on, I do have this expansion port up here. This is the same type of expansion port that comes on this board. So they've labeled that XBus265 from Western Design Center. This is using the same format. So if I happen to have peripherals that use that specific format header, or I can just connect in wires, of course, and do my own expansion or make my own expansion PCBs that could click in there. I've got this LCD here. This is basically a 480 by 320, 2 bytes of color. And underneath that LCD is another versatile interface adapter that is driving this LCD, along with an IC that is for managing my interrupts from across the system. I have then a third via or versatile interface adapter down here. One of the things that's connected to is a real-time clock, and I'll be using SPI to manage that. I will also connect SPI to this. I have an SD card reader down here that I've connected in. And then I also have an additional free port on that versatile interface adapter, and I put in headers for 3 more and support for 3 more SPI devices. So I can connect 3 more devices there that are SPI and decide what I want to do with this extra VIA port at some point. So this is essentially the board. You know, that I got standoffs. There's some components, some passives on the bottom of the board, but really all the active components are up top. So let's maybe fire this up. So first things first, this probably won't all fit on the zoom level I've got here, but I will maybe just see if I can't make this mostly fit at least. So I'm going to connect up power using the Saber connector here, and just going to twist that around and get this plugged in. And actually, maybe what I'll do is zoom back on my camera. Let's do that. Okay, so here is a little bit zoomed back version. And I think I'll see if I can turn off the overhead lights. Just to get rid of that overhead glare there. Okay, so there's my board. Here's my power. I better get a keyboard here. So I'm going to slide all of this up. Grab my little keyboard, get that plugged in. And then I have a data only cable going to my PC. There's no power supplied in this. Basically, I'm running it through a little switchable USB hub where I can turn power on and off. I don't want power. I want power coming through this connector just so I can control it, monitor it, etc. Oh, let's see. I think that's all I need for now. And so over here on the side, I have TerraTerm running. It is set up to look at COM6 on my PC, which connects to this FT232 here. And I'm going to go ahead and fire it up. So as it comes up, I have the supervisor set to delay not quite a second, about a second. And so a couple things that I can watch as this boots up that just kind of helps me understand. And I'm going to turn this on and off a few times, but I now have status lights down here. And let me go back to this zoom level. But I now have LED lights for each of the chip selects from 7, 6, 5, 4, 3, and 2. So the bottom one is chip select 2, but then I right above that have the static RAM, chip select 3, the flash, chip select 4, and then 5, 6, 7 that I'm using for different things. And I'll maybe pull up the way I'm doing the I/O control on that, or the address decoding here in a little bit. But I can watch that, and one of those for the flash is where it should just ultimately stop and stay lit up because I have a loop that's running off of the flash. So if it completely boots right and it's running the way I expect it to, most of the time this chip select for the flash will be lit up. You will also notice that I do have LEDs indicating serial activity, so there's a transmit and receive there. You'll see those flash when it's first powered on, but then once it actually starts outputting to my screen, you'll see one of these flicker as it's writing to my serial. And then I also have LEDs for a few of the ports that are available for me just to use. There's not much unused. I have one little header here with just a handful of I/O that are not used yet, and I do actually already have a plan for those, and I'll come back to that in a different video. But I'm using everything on this microcontroller, or will be, minus a few pins is all I won't be using here when it's all said and done. So when I turn it on, I'm looking at these. I'm watching for the flashing for the USB serial activity, and then once it gets to the end of my boot up, I do have it toggle P64, which will be the bottom LED over here. So if that lights up, and I also turn on the CS2 LED over here, so if those two light up, I know I'm at the end of my startup. And what I should see by then is the LCD gets initialized with just a cursor, and this goes through, this TFT goes through its little demo code that I showed in a previous video, where it just does color bars and a little ship that flies across it. So okay, I'm going to turn it back on. Saw the quick flickers there. I see it's reading flash. It's running through that. It's already initialized the LCD. Now in this case, I did notice, I'm going to have to put a delay maybe back in my code. I had shortened a delay, and if you add a certain delay, then this will initialize every time. And I see it's not quite initialized the way I want it. If I hit reset, I bet it'll initialize. And they're properly initialized. So that's just a little startup delay factor. I probably could fix that either by increasing the delay down here on the supervisor, or I have in my code a little delay that I really cut way down. I'm going to bring that back up a little bit so that this always initializes correctly. So as I'm looking at this, I did see that this LED is lit up. These over here, I have a pretty weak resistor. I'm using like a 3K to drive those LEDs. Basically, when those enables go low, which is active, it'll also pull the LED on, coming from basically a 3K resistor. So those aren't very bright. They show up fine for me here. The screen, the camera might not pick them up real well, I guess. These over here, I'm running at a higher voltage with a lower resistance, so they're brighter. And same with the ones up here on the USB serial. And then I have a power LED too, I guess. So maybe with this in camera frame, I'll do one more reset, and maybe I'll even just turn power off and just test a cold start on it again. So there's a delay, there's a screen reset, then I clear the video memory on the other screen, do the little spaceship fly across, and then this LED and that LED for CS2 and this P64 are lit up. So at that point, I can do things like test on the keyboard. And so if I come in here and type in hello world, you can see keyboard is working great. Really, everything's working that I have had in the previous videos that I put into this. So I'm really happy with that. Honestly, I'm surprised it all fired up without any issues. So no soldering issues, no missing components, no bad schematic design yet that I found. What I have yet to do, and this is probably going to be in my next video, I'm going to work on building a power on self-test that tries to test out as much of this board as possible during power on. Now I have this little speaker I can use for some audible cues. I of course have this LCD working. I also have this LCD working. I need to get fonts working on this LCD, so I have to implement my own font support, just like I did on my VGA. It'll be the same type of code. It'll just be I'll be writing to this little TFT screen instead. But I'll do a power on self-test, and when I do that, I'll test this static RAM, which should be working at this point because I'm using some of that already for some of these routines. But then this additional 0.5 meg of static RAM I'm not using yet, so I need to test that. I need to test this 2K dual port static RAM, make sure I can get to it correctly. And I also need to test this secondary external flash. This is an additional 0.5 meg. Most of which is usable. Some of it is already reserved for the previous flash, I believe is how it works, but I'll be able to access the rest of that 0.5 meg minus the initial 32K that was cut out. And then I can start working on SPI routines, and I can test the SD card reader. I can test the basically this RTC real-time clock over here. So I've got the battery backup, real-time clock, so I can write routines through SPI to read the current date time, set the date time, things like that. And at some point I'll get into really writing maybe a little basic monitor / OS program or OS for this. But I just need to slowly kind of build up on that. That's going to take a whole bunch of effort. But I want to have something that essentially is, I can see either on the VGA output or on this screen, a prompt. I can type commands and have it do different things. So I think that is it for now. I just wanted to kind of post an update, just showing that I am transitioning from, these other little boards to this board as my primary. The board that's coming is the same size as this. It just has other functionality on it. And I'll see if I have success with getting that up and running when that comes in. That'll probably be a couple of weeks yet. But this board, I have a great deal that I can work with coming up. I've got all kinds of ideas, and I posted some of those on the blog page that I've been running. And I am starting a new blog post with this board build. So the one I have has quite a bit on it already. I'm going to just roll into a second blog post and really focus on this board and the secondary, the AV board that will be its companion board that will come up here in the next few weeks.